Thank you for joining, everyone. So today we're just really going through those technologies, some of which may be new to Trust, and a lot of technologies really around decarbonising gas on site. We've got talks from a number of companies who will take us through, like I mentioned, the decarbonisation of gas on site, the decarbonisation of the existing CHPs, offsite generation of electricity, which is mainly around solar farms and flow battery technology. And there'll be a quick update on the workshops in IEM next week as well. So hopefully it'll be quite an engaging one, and I'll be there. Hope to see most of you there as well. Thank you.
And Stuart's arrived, so that's
Great.
relief. That's all. Drop the next slide there, Lorna.
Yes.
Okay, anything there you missed there that you want to cover?
I think I've covered it really. Okay. Yeah, I'll just hand over to Stuart.
Okay, well, there's a gap in between. I'll do the map. Next slide, please. Okay, so the talks have all been around the different routes to net zero, and the easy ones like geothermal and hydrogen and green D, those are easy ones. This is a workshop for the ones that haven't got it easy, and it's to do with other techniques you may not have thought of other than heat pumps to get you to net zero. So that's kind of where we're focusing today. Next slide, Lorna. We have all the Trust, the top 209 emitters on a database, on a map thing here. This map, we're showing just the Trusts that don't have an immediate route to net zero, i.e. geothermal, hydrogen, or green district heating. So there are a lot of Trusts who are in the same boat, and that is the boat of the hard way to net zero. Next slide, please, Lorna. Okay, if we can hand over to Stuart, and thank goodness you made it, Stuart. We were starting to panic. I'm starting to panic again. Stuart, are you with us?
Yeah, I think he's on mute. Did you?
Yeah. Let's try again, Stuart, and see if we can hear you.
How's that? Is that any better?
That's much better. Yeah. Right.
Okay, that's good. Right. Well, thank you for bearing with me. I'm a little bit out of breath because I should rush to get here myself, so forgive me. Next slide, please. Good. Well, for those of you who haven't come across methane pyrolysis before, it's a very relevant process for a lot of sites in the NHS, because effectively allows you to take your existing gas feed, to decarbonise that gas feed, and use hydrogen and replace the gas with hydrogen in your boilers and heating mechanisms. Effectively what it does, it's a chemical process which doesn't involve combustion, and it effectively takes the carbon straight out of the gas. It's a system which effectively reuses a lot less energy than electrolysis, and of course, as I say, it substantially reduces the carbon footprint of the systems. It can also have a very small physical presence on site, perhaps only just taking a few sort of car parking spaces. Well, effectively, what we can do is take existing gas production and distribution assets, so the 280,000 kilometres of pipe that exist in the UK, effectively use that rather than worrying about how do we create hydrogen and get it to the NHS site. Now, there's an interesting byproduct, because the carbon's got to go somewhere, because it is in the gas. And what we effectively do is we convert the carbon in the gas to carbon black, which is a solid black powder. And it's easy not just to sequester, but also has significant commercial value, because it's used in tires, inks, and other many applications, including batteries, and is a very safe way to get to use that carbon. Next slide, please. Here's a sort of a diagrammatic explanation of it. And of course, what we do is we take natural gas and biogas, and we effectively use a renewable electricity, assuming you have access to it. and put the hydrogen straight into a clean way of heating the site and take the carbon black away in a clean and safe way. Our generators can effectively generate roughly about 1,000 kilos of hydrogen a day. And because we're not actually shipping the hydrogen to site, it's the lowest cost hydrogen that you can have on site, unless you're just down the road from a large scale hydrogen generator. The unit itself captures the carbon, and that is effectively we will ship that away from the site too, so you get no issues about what do we do with the carbon. Next slide, please. So to give you a feel for it in terms of where the system boundaries are, so we would expect to use your electricity and your gas. So you maintain your low cost deals that you've negotiated with those suppliers. We would supply you with, of course, our box. We'd supply you with a compressor and a reservoir, because that makes sense just in case you have peaks and troughs in demand. We will remove the carbon from the site, and what you'll be left with in this particular example is 250 kilos of hydrogen a day. But of course, if need be, we can either stack the generators or increase the generator size. So initially, we would probably supply you with 120 kilo or a 250 kilo hydrogen a day generators. You can see there in terms of where that turns into kilowatt hours per day. We can use ubiquitous low, medium pressure natural gas, which you already have, and standard three-phase electricity. And we will maintain the system, operate the system for you, and remove the carbon, as I've said. Next slide, please. The key advantages of it compared to the other main methods of getting hydrogen to you, being steam methane reformation, electrolysis, and our way, is that we have significant breakthroughs in terms of lowering CO2 emissions, significant breakthroughs in terms of total electrical energy consumption, 80% lower than electrolysis, and that's a really big figure. Delivered cost, because we're making it on site, there is no delivered cost. And of course, we have this rather peculiar thing, is because our carbon black that we produce is emission free, we have massive reduction, indirect emissions from carbon black, which is produced in the traditional way. Next slide, please. And again, just to stress this point, it's the problem we often have when we speak to people who have listened to hydrogen being green, is that they have trouble understanding that electrolysis is not really terribly green as it stands right now. If you've got a grid-powered electrolyzer, the emissions from it are actually quite high because of the actual gas and other generating tools that are being used to get that grid energy to you. For us, because we use so little grid-powered electricity, we do use some gas, and there is some gas emissions further upstream for us. We can't really deny that. But when we put ourselves against electrolysis, there are significant improvements. We use a tiny fraction of the carbon emissions that we emit, a tiny amount that an electrolyzer would, both now and in 35. So I think we've got a good positive carbon story for you in the steam methane, so should I say, or a Suizo process. Good. I think that's pretty much my lot. Is there any more slides? Or well, we get one more. Yeah, just to give you a cost in it. Yes, exactly. So excuse me. And that's a core economic advantage against electrolysis as well. So in our process, to make a kilo of hydrogen, we basically consume about £4.20. However, we generate about £2.70 worth of carbon black at the same time. So net, we're about £1.50. create an electrolyzer with the equivalent prices, and again using Bayes figures, an electrolyzer will require about £6 to make a kilo of hydrogen. So you can see there's a core economic advantage doing it with our methane pyrolysis way rather than electrolysis. So I hope that paints a compelling picture, and I'll hand over to Sandy at HiROC, who'll tell you a bit more detail too.
Brilliant, many thanks, Stuart. That's fantastic. My name is Sandy Abathno. I represent HiROC, and if you go on to the next slide, please, just to very briefly introduce us. We have a process which is chemically very similar to the SWISO process, but the physics is slightly different. We use, instead of methane pyrolysis, our process actually is an electrolysis using thermal plasma of hydrocarbons. So, and that could be fossil fuels, natural gas, biomethane, as Stuart mentioned. We founded in 2019. We've got 100 employees plus now in the UK and around the world. And we are, well, I'll talk about our kind of rollout plans in a second. If you go on to the next slide, please. So if you have the box that Stuart has just described, where you've got a fossil fuel or a hydrocarbon, biomethane, biogenic hydrocarbon, and a relatively small amount of electricity going in, and carbon black and hydrogen coming out, there are a huge potential range of applications for that. And we're here to talk about just one of them, around decarbonising existing natural gas-fired processes in hospitals. But we have, unfortunately, kind of fossil fuels are incredibly energy dense. Our economy is based on fossil fuels. It has been for the last 150 years. And they're amazing kind of energy carriers compared, for example, Stuart mentioned the comparison with hydrogen derived from water electrolysis. Water doesn't really have any energy inherent in it. You start off with water, you apply a whole load of renewable energy, and you end up with green hydrogen, which when you use, you end up back at water again. So effectively, all the energy comes from the renewables, and it's not a hugely efficient kind of energy storage mechanism. Whereas the difference between ours and the SWISO process is that we're using all the energy that is in fossil fuels and biogenic feedstock, and just taking out the bit that's causing us the problem, which is the carbon, leaving the good bit, which is the hydrogen, which we can use in existing applications without the emissions. So a huge range of options. It's also worth mentioning, clearly, if you use biogenic feedstock, then that's atmospheric CO2, which you're sequestering in building materials or in soil, and you end up removing carbon from the atmosphere. So that's kind of the more kind of exciting and transformational element on the right hand side. Diving into that industrial and heat piece, if you can go on to the next slide, please. We have Centrica joining us after this. So John, I think, is following me. Centrica are one of our investors. We have a couple of partnerships which I thought I would just highlight with them, or a couple of value propositions we're developing together. The first one, where our first units are operating, is at a gas peaker plant in North Lincolnshire. And we're working with Centrica, funded by the NZTC, the Net Zero Technology Centre, to see how we can decarbonise peak power generation. So make hydrogen when energy is cheap, and flow it through the gas turbine, the reciprocating gensets, to generate electricity when the wind isn't blowing and the sun isn't shining. I guess more relevant to this conversation is the industrial decarbonisation, kind of pairing our technology with CHP technology, which already exists, to as Stuart was talking about earlier, taking the carbon out, the problematic element, using our existing gas network, existing electricity network, no new infrastructure, kind of major infrastructure required. We're just taking out the carbon and using the hydrogen instead. Next slide, please. Just a little bit about where we are, and actually the importance of making sure we have a very robust technology and product development roadmap. As I said, we were founded back in 2019. Our demonstrator was operating at our facility in Hull last year. You can see our 2 pilot units deployed at that Centrica power station I mentioned in the middle. And they are that's kind of where our main technology and product development is taking place, and we are kind of on track to deploy kind of multi-torch unit, a commercial unit at commercial scale next year and beyond. So and that's why we're looking at confirming the viability of those units in a wide variety of use cases, including things like hospitals and industrial decarbonisation today. So, you know, we know what that product will look like, and we're keen to talk about how it could be deployed in places like hospitals. Next slide, please. If we are deploying those units in hospitals, there are obviously a few things that we need to think about. Evidently, the reason that we're all doing this and having this conversation is the need to decarbonise across scopes 1 and 2 and 3. You know, Stuart mentioned the fact that actually a lot of the impact is displacing carbon black. Producing clean carbon black displaces a very emissive process, and so, you know, it's actually scope 3 emissions of other users of carbon black, which is a kind of indirect benefit of this technology. The economics clearly have to stack up, and actually there is support. The UK government are consulting and rolling out the hydrogen production business model, which is there specifically to bridge the gap. At the moment, there is a cost differential between fossil fuel and cleaner fuels, and that's an issue. So the reason that the hydrogen production business model is there to bridge that gap and to ensure that the economics for users stack up. Clearly, we need to understand footprint, both for the TPE unit and the carbon handling. Evidently, there can be no downtime, there can be no risk of disruption. So we would need to make sure that would happen, and there's kind of suitable resilience so that you don't lose heat. There are considerations around vehicle movements, around capacity and gas, capacity and supply. Clearly, permitting and planning is always a challenge. And as Stuart and I both mentioned, you know, the fact that it's just a kind of a plug-in solution to use existing infrastructure, I think is very appealing. Next slide, please. I'm not going to go into detail on this because it's a lot of words and it's all about the hydrogen production business model. Suffice to say, there's government support available to support individual use cases to bridge that gap between low and fossil based fuels. And final slide, please, just as an illustration. So a deployment of a HyCom 4-torch unit at a hospital, just as an illustration, would produce up to 126 tons of low emissions hydrogen a year, which is over 4 gigawatt hours. Avoid up to 1,500 tons of CO2 entering the atmosphere, both directly and indirectly. Generate an awful lot, 400 tons of valuable carbon black, which would displace, as I said, those a significant portion of scope 3 emissions. Would use existing gas and electricity connections, requires a fraction of the electricity of water electrolysis, because we're releasing the energy that's inherent in hydrocarbons as opposed to just ripping apart water, and would fit in the footprint of a standard shipping container. So, bit of an illustration, and really happy to answer any questions later. And with that, I think I'll hand over to John.
Hello, afternoon, everybody. I'm John Hyde. I'm head of sales for heat and mechanical solutions for energy for Centrica Business Solutions. So, as we just heard, we really help join up the dots between the HYROC technology and the NHS. We work very closely with them, and we have a stake in their business. And currently, I'll talk about that trial that's underway at the moment. What this is all about is zero CO2 hydrogen. So it allows us to have that hydrogen for use at point of use, and it only takes 1/5 of the energy required by electrolysis. So this is a very efficient process. This can then be used in boilers, CHP, without further processing, and it allows us to use that at the times when renewables are not available. So it's really shifting that energy to a point at a time when we can use it. Okay. The amount of hydrogen on site also does not constitute your site becoming a coma site. So that's really important to know that as well. Okay. Next slide, please. So how we implement this is through existing technology, combined heat and power. We partner with different suppliers, and we have available to us the equipment that can use 100% hydrogen right now. As you probably know from CHP installations, the return on investment can be quite good. And with this newer technology, you can be set up to use natural gas as you currently do, and then hydrogen when that comes on board as well. Along with different blends of up to 50%. It can be optimized to work out of the box right now, or it can be set up to future-proof you as well. And the purity of the hydrogen coming from the high rock is just perfect for combustion. So there's no issues with that. The example of this is on the next slide that we're currently underway. We alluded to this earlier. This is where we're injecting into the grid. So this is a different scale altogether, but it shows the confidence that we have to reduce the marginal carbon across the whole country on these peaker plants. So the more that this is used, the more we all benefit across the country by reducing the carbon at those times these peaker plants are kicked in. This is the first time it's been used. So it's a really positive step forward. As you can see from the plans ahead, scaling this and moving this out is a big part of our strategy for next year. And we are a solution provider that have done similar things to this with the NHS, and we plan to do that in the future. So I think that's it for me, nice and quick.
Good afternoon, everybody. I'm Helen Brindle from Vital Energy, and here to talk this afternoon about the solar farm experiences we've had. If you're looking to get to net zero by generating from solar, you typically have to go to an offsite location just because of the land area that's needed. So there's a few ownership options available. It could be trust-owned land, council-owned land, or private. In the case of Wolverhampton Trust at New Cross Hospital, this land was owned by the council. So it was originally a coal mine, then used as a landfill site, and now we've just built a solar farm there as well. So excellent use of land there. So that the land ownership option has been through a lease between the council and the hospital trust. Obviously, it's a project that the council supported, which was helpful in getting the planning in place and other approvals that were needed. So in designing the capacity there, I have to look at the requirement of the hospital in terms of load, but also maximising the area. So the two things were balanced there, and then looking at the funding available, and all that was used to design a 7 megawatt capacity solar system, which is about 11.5 acres, I believe, is equivalent to about 22 football pitches, trying to put that into context. And with the connection is a private wire going back to the hospital. So that's been combined with other technologies, such as heat pumps. So it's a great way to electrify the heating system on the site. At the time this was built, this was the largest single source of green energy for a hospital, but it just shows that great things can be done. Can I have the next slide, please? The benefits of solar are quite well known, but clearly it's offsetting imported electricity, which is saving the hospital round about £1 million a year. But because all that electricity used will be green energy, it's saving just under 1,500 tonnes a year. This hospital, we believe, is going to be taken off grid, well, not necessarily off grid, but completely displacing grid for over 250 days a year. Got another hospital in Wales that which is operational, and we're actually seeing through monitoring that is being taken off grid. Solar farm is supplying all of the electricity. Can go on to the next slide, please, Laura. Thank you. There's a number of challenges, obviously, with building a solar site. Possibly one of the biggest ones in the first instance was ecological risks. So anything that you do have to be sympathetic to the site. So looking at having things like an ecological project manager on board. The case of Wolverhampton, the design was changed to accommodate some badger sets. So the panels were moved, the location of the fence was moved, holes put in the fence so that they could still go wherever they wanted. And happy to say that badger set hasn't been disrupted and is still there. Number of other ecological issues could be bird nesting season, like programming any site clearance, any watercourses that need to be protected. Obviously, they're risks in any construction, but the sort of sites that you'd be choosing for solar farms, because of the area and location, definitely important considerations. The private wire connection can have its challenges itself. In this case, it was a 1.5 mile private wire. So it's down a highway, and you'd pick the route for various reasons.
We've lost you, Helen. You've gone on mute for some reason.
Thanks, Clive. I don't know what I touched.
We go. I don't know, but you do from the private wire bit again here.
Okay, sorry about that, everybody. So the private wire, the route that you choose, you take into consideration any difficult factors that would be on the way. In this case, we avoided going near a train line because the permissions were seen to take a long time, but we still had to go over a canal bridge. So various permissions about going into a bridge, and because it is the supply to the hospital. Various approvals are going to be needed from planning and highways and coordinations with other services. In one case, on another project, we went across a mains high pressure water main, and that took a long time to get approval, and all had to be hand dug. But if you're going over too much private land, there'd be a lot of way leave agreements. So whilst it might be easier to grow across multiple farms, getting those agreements in place to suit the programme is quite possibly more difficult. One of the big challenges on this and many other projects would be a DNO connection and getting agreement with National Grid. Seen that across the country, but I think early discussions and getting the right people in place could help that a lot. So there's various experience on teams can help put those proposals together and get the grid connections, and also making sure that you've got the right connection at the hospital. A big benefit would be risk transfer of this in terms of long-term operation, maintenance and life cycling. An important part of that would be the ongoing monitoring of the system. So then you're picking up that everything is performing and nothing's dropping out. So if there's a performance guarantee, you'd be looking at making sure that everything is in place all the time and have very quick response times for any repairs. So happy to pick up any questions on that at the end. But that's me for today. Thank you.
Okay, over to Dan.
Hi all, hiya. I'm Dan Tenekun and I'm from RE24, and we provide offsite renewable power for organizations. If we jump into the next one, please. Yeah, so picking up where Helen stopped. So essentially, when any of your trusts, when you want to get renewable electricity, so there are primarily 3 ways we can get it. So obviously, from a most economical and then the most carbon savings wise, the best thing is that if you can do some on-site renewables, so that's the best thing to do. But obviously there is a limitation of doing on-site because we have limited roof space, limited ground around you, and then we can't do much wind, etc. So then the second option is, as Helen articulated, it's about the getting private wire options. But once again, there are some. Yeah, so again, it's good, and one of the biggest benefit of the private wire is that you can avoid transmission and distribution charges when you get the private wire options. So obviously, if you can, that's a good option to go for. There's another limitation in the private wire. It's simply on the site availability around you. So if you look at a trust, your annual energy consumption could be electricity consumption. It could be 20 gigawatt hours per year, 10 gigawatt hours per year, and then so on. So it can be higher. And from a private wire solar, there's a limitation of land we can find around you. So after you do the private wire, we still have a last option available for you, which is the offsite power purchase agreements. So I'm going to spend a bit more time talking about that offsite power purchase agreements. So in there, primarily there are two ways we can get. So one probably you haven't looked at before, so which is we can generate power from one NHS trust. So essentially, if one trust has excess power and that trust can ship that excess power to another trust. It used to be a period we could do that only for bigger volumes. I'm talking like 20 gigawatt hours per annum, 50 gigawatt hours per annum, and so on. So big volumes. But more recently, it's been significantly lower. For example, we have done a project like that one. So we shipped only 600 kilowatts of rooftop power from Kent, and then ship that into Midlands. So it can be done, and then and people are doing that. So for one trust, it's like the trust who has excess power. That's economical for them to do that because they can get long-term revenue from the other trust, and the trust who hasn't got that excess power or hasn't got renewable, then they can tap into the cheaper renewable electricity from the previous trust. So the second option is that, again, even if you can't get from the renewable energy from those trusts, you can go into the market and then get renewable from bigger solar farms and wind farms, which is out there in the market. If we jump to the next slide, please. Yeah. So why should we go for these power purchase agreements? Is mainly because it's savings, because we can get financial savings out of it. How do you say, like, it's not there's a catch here, but then we can get more savings if you go for long-term agreements. So the longer the term, the better the savings we can get for. But also it's from a sustainability aspect as well. It's savings from scope 2 emissions, and then when you go through that approach, I think somebody's not on mute. Yeah. So if we go through this PP approach, the other benefit is that is rather than getting from a green tariff renewable electricity. So this is purely you are getting from the source, so it's hence more sustainable. It's more greener. If you jump to the next one, please. Yeah. So then when we say it's like cheaper, so how does it look like? If you look at some of the renewable energy projects available right now in the market, we can go for next year renewable energy projects, which starting the price at roughly about 8.4 pence per kilowatt hour. So then these ones we also need to take into account. So these ones would have renewable energy guarantees of origin attached to them as well. So if any of you purchased green electricity recently, you might realize the price of the REGOs, the renewable energy guarantees of origin, have gone significantly up. So the REGOs, I'm not sure who's familiar with them, but just to give a context a little bit. So the REGOs were roughly about 20p, 30p about 18 months ago, and from April this year, government stopped any of the European guarantees of origin coming to the UK. So it's I think we need to another person not to mute. Yeah. So so then from April of this year, the prices have gone up significantly. Now, if any of you got a new green tariff from your electricity supplier, you would have realized the REGO price have gone significantly high now. So it's roughly the market price. So that is about 10 pounds per megawatt hour, 13 pounds per megawatt hour. So these ones include that those REGO certificates attached to them as well. And just one thing added to that one is that if you go for the longer term, so the longer term prices are even a bit more cheaper. So we can get a 15-year agreements, roughly about 7 pence per kilowatt hour. So again, here previous presentation we spoke about gas, we spoke about different other measures. So here we are fundamentally talking about electricity only, and then offsetting your scope 2 emissions from electricity. If you jump to the next one, Lorna. Yeah. Yes. So then whether you get it from another trust or whether you get it from renewable energy project, they all go through your incumbent supplier. And if your incumbent supplier doesn't facilitate that, when your supplier comes to renewal, there are a number of suppliers who would facilitate this one. So we need to get it. We need to get the power through any of those suppliers. But also, there's another commercial structure we can do that. We can do that as well. People who are familiar with that might have heard something called a virtual PPA. So again, we can do that irrespective of your electricity supplier. And just a bit of a journey drawn out just to like make it like highlight for you to say that because these are longer term contracts, it's almost like your energy performance contracts. When you go for energy performance contracts, we need to go for a bit of approval process internally and then go through different contract stages. So similarly in here, we need to go through a contractual process as well, but typically it will be like 2 to 3 months contract process, like irrespective of whom we are going through. If you jump to the next one slide. Yeah, so this is just articulation say that it's actually like if one trust sells power to another trust, we can put them into a portal, so other trusts can see that, but also through the portal you can see all other renewable sites available as well for you. And the good thing is it's almost like typically we would have an energy analyst. I mean, like we would work on the Excel, look at our profile, look at the renewable profile and do that. And through the portal, it'll be taking your MPAN details, and based on your MPAN, it looks at your profile and then it puts the renewable profile as well, and then see how much it matches your renewable profile and gives the price information and then other contractual information as well. So essentially it's a like way to make the renewable purchasing a bit more efficient. If you jump to the next one, please. Oh yeah, if you click one more. Yeah. I think it should jump to the next slide. And no, one more down. There we are. So last slide. So this is about bit more about greenhouse gas emission protocol, how those emissions will be reported. So people who have reported emissions on the greenhouse gas protocol, you might be bit familiar on this one. So, but essentially the key point is that if you take any private via renewable PPAs, and the scope 2 emissions is we only report one emission, and then that's 0 scope 2 emissions in there. And whether it's from another trust or whether it's from a separate solar farm, wind farm, or hydro, etc. So those ones goes to as offsite renewable PPAs, and those ones under the protocol we are reporting under 2 approaches. So first under market approach. So under market approach, we say it's 0 scope 2 emissions, but then purely for comparison purposes, there's a location-based approach we need to present as well. So because it comes from the grid, obviously there's no private wire to you. So in the location-based approach, it uses the UK grid emission factors in there. So we report emissions on two approach. One market, the other one is comparison purpose on the location basis. That's it from me.
Okay.
Oh,
right.
sorry. Yeah, we can skip that one.
Okay. Well, thanks, Dan. We're probably getting a bit tight on time. Right. As happened before, Invinity, who are flow battery manufacturers, stood us down. They haven't appeared, but we're aware, like solar is an established technology. Time shifting the use of electricity is a way, when you've got heat pumps and the rest of it, to try and green your site up. And we're familiar with lithium batteries, but there is another battery technology called flow batteries, which are scalable, and effectively the electrolyte gets pumped past the electrode on the battery, so they're scalable. Next slide, please, Lorna. And the nice thing about a flow battery also is a very long life and a very slow decay of that life over its lifetime. So you can be talking about safely having a battery that you're using every day, charging and discharging when it suits you, and it's not decaying like a lithium battery is. So we see this as something that can be used to stretch the hours from solar generation, to stretch the hours of CHP generation, or is to help you with power, getting it when you need it, as against when it's being produced. Next slide there, Lorna. Okay, and here's some specifications from the battery here. So I would just take from this that a large lithium battery on your site might be 1 megawatt hour, which would run the average hospital for a percentage of an hour, which is okay, but it's not very long. If you want to run the hospital for a number of hours, then you need a different kind of battery, and that's what this offers you, in a renewable form. It's new. It's not new in the country. There are lots of them in the country, but they support the national grid. For hospitals, they're new, and that's why the flow battery companies are being a bit snotty with us. But we will tame them if it turns out to be useful to you, because being able to time shift electricity on site or even off site can be very useful. The technology costs less per kilowatt hour than lithium does, but it does have a cost, but it has a much longer lifetime. So if we get interest from sites wanting in that, we will pick it up with Invinity, and we will eventually get them tamed. They have partnered up with EDF, and EDF are starting to get their head around it themselves. Next slide, please, Lorna. Okay, so today's talk's all about getting sites with no direct route to net zero other than heat pumps. We've chosen to treat heat pumps as slightly different because we're assuming that most people are familiar with heat pumps. They've been around for a while now. PSDS supports them. So we haven't concentrated on that. But we've actually changed our view slightly, so I'll tell you about that in a second. So if you want to go to net zero completely, hydrogen delivered over through a pipe to you, or geothermal under your feet, or clean district heating are ways of going to net zero very easily. And of the 209 biggest emitters in the NHS, 50 of you are lucky enough to have access one way or another to those, but the rest of you haven't. And that's so we've shown you how you can still continue to use natural gas in the cleanest way possible through the first part of this talk. And through the second part, if you're using heat pumps, we've shown you how you might try and address one of the biggest issues with heat pumps, which is the electrical cost in a green way. So that's what this talk tried to cover for you. Next slide, Lorna. The whole NH Power is here to help you. It's a collaboration of you and you and you. I know I'm talking to you, but all I'm prepared to do is harness your combined energies to everybody's good. But if we're going to get the 209 sites to net zero for 2032, that's about 8 years away. And if you are going to change a site, you might be talking of 4 years of work. And then to that, you might have to add governance and approvals of various sorts. So 8 years is not very long, and there's no way collaborating. We can all leave it to the last second and hope to get this done. We can have 2 4-year cycles, or we can kick a 4-year process off in stages annually, but just give us time to help you. And if we're going to share procurements and share knowledge, then obviously we need to start the process now so there is something to share. Next, Lorna. So the NH Power program has been doing a number of things for you. We're just finishing the August and September. This is the last talk. They're all gone up on the website if you want to look at them. The workshops are next week at IEM on the 10th and the 11th. Please come to them. You've had the invites. That you should leave having met the people you've seen today and others face to face. You can talk to them, get their business cards if you want them, ask them the questions you haven't thought you wanted to ask. And then there'll be road shows at the end of November through December and into January, where I'll attempt to bring a solution of all the technologies close to your site. I can't promise to have every speaker there because they're all busy people, but I will have enough information there to allow you to cost your project and work out what it's going to mean for you. Next, Lorna. So at IHEM on the 10th and 11th, we have the workshops. We have the geothermal one with the minister on, or not the minister, the MP who's in charge of this on video link. We'll have everybody else in the room. District Energy, we'll have British Geological Survey, who've looked at all your sites at a top level, and the rest of the team there. And we'll have the Net Zero, the team you're hearing today, appearing as well. Those are all on the first day of AHIM. Next, Lorna. On the 11th, we've got Hydrogen Day, and because two of the speakers today have been telling you how to produce hydrogen from gas, I've invited them to a Hydrogen Day as well. So they will appear, they will have two chance to see Stuart and team and Harrock on that day. And then we have put in a heat pump case study and learnings after it, because Mary said to us, look, there are a lot of trusts that use PSDS money, or already got heat pumps, or have got to use heat pumps. Can we help them? So we've got people there starting with the manufacturer and why and what and how and so on, through an specialist installer and the learning for that, and then followed by two very interesting and very different case studies for you at that session there. Next slide, Lorna. In conjunction with that, we have the Energy Theatre on the main floor. Both the workshops and the Energy Theatre are free to attend. A lot of the speakers you've heard today will be speaking at the Energy Theatre. There it's gloves off, because they don't have to be careful about competition and fairness and all the rest of it. They can just tell you it straight from the shoulder. So you can grab them at the workshop and go to their talk, or vice versa, and see the whole picture. Next slide, please, Lorna. So by the end of AHIM, I expect you to know which technologies will get you to net zero. And for the road shows, I expect you to understand those in more detail, have an idea of what money we're talking about, and what revenue impact we're talking about, and to have SOC level, strategic outline case level costings and savings for your plan. Plus, we'll make certain support tools available to you. Next, Lorna, we should just about have got there now. The tool sets we're developing that'll be available by the time we have the road show is the map. The map you saw has all the 209 emitters on it and a lot of information about them. When you register for the workshop, you'll fill in a very, very short questionnaire you can do on your phone if you end up having to do it on site. That just allows us to put you in the right part of the workshop, and also informs the costing model that we'll then use when we come around the countryside. So you'll get access to the map. By the time you come to the road show, you'll get access to a model that allows you to cost the options for your site at obviously a cost range. We can't say it's going to be exactly 3 million for your site, but we may say it's between 2 and 4 million model there. So we'll have those, and the draft dates are these dates that you can see now. We have run really late today, so I can't really take questions, but I've noticed every question's been answered. Except there's an interest in flow batteries, which I'd like to pick up an AHIM if that's okay. Otherwise, Peter, I'll try and send you something. But you've got the data sheet from Invinity now, which is a step in the right direction. So unless somebody's really pressing for something or where I need to let you go, is there anybody who's desperate to say something? Otherwise, I'm going to thank all the speakers and we'll move onwards. Okay. Well, can I thank you for coming? Can I thank the speakers? You've got the best people in the business here talking to you. So I hope that you value the contribution they made, and you can meet them face to face and shake them by the paws next week when you pitch up at AHIM. And you don't even have to pay to join AHIM, because you can get all that glorious goodness for free. Okay. Well, thanks, guys. Thank you for your time.